Our last piece is to talk about something called continuous compounding interest. And continuous compounding interest just means that we are always gaining interest on the account at every second and every moment of the day. The problem is we're only earning fractions of the pennies. So even if you check your account at the beginning of the day and then check it at the end, it may not seem like it's grown a whole lot because you're only adding fractions of pennies on at every moment. So what we're going to do is talk about what this formula is to be able to compound all the time, no matter what. So to do continuous compounding, we need the use of a very special number called E. And a lot of you are saying E is a letter, but E also represents a number in math. You might have seen it used in chemistry a few times, or you might have seen it come up in a couple of other science classes that you've seen to this point. In your calculators, if you look at the graphing calculator, there are two spots where you're going to find E. One of the spots is right here where it says the ln, and right above there is the e to raise to the x power. There's another spot above the division symbol, the division button that's on your calculator. So if I turn my calculator on and just hit this division button, I have to hit shift first and then hit the dividing button. It'll tell me that E has a value of 2.71828, so on and so forth. That is what E represents. E represents 2.718281828, so on and so forth. It's kind of like the number pi that just keeps going forever. It doesn't have any repetition. It's an irrational number. Same thing with the E. It is this very, very special number. Where E comes from is actually what happens with part of our compounding interest formula. It's this part right here that we're talking about, the 1 plus r over n. What happens with that as we let time go on, as we let n become more and more and more times that we're compounding in the year? So we're going from the number of days to the number of hours to the number of minutes in a year to the number of seconds in a year. As that gets really, really large, it actually turns into the number 2.718. That's pretty much what's going on there. So all we're going to do is we're going to replace this kind of situation or this part of this with the letter E. So the model does get changed around just a little bit. We still have A, which is the amount you start with. We're still going to have R, our rate, but this time it actually moves up into an exponent spot. And then we've got this E that's in here, and that E is just the E that you will find in your calculator, no matter what you find. If you're using Desmos as your calculator, you can type in the E, and it will recognize it as this number E that we're referring to here. So what we're going to do is walk through a couple of problems using this new formula, and we don't need anything else. So we're going to put $1,000 into a savings account with 6% annual interest. How much money will be waiting for you at the end of 4 years if we compound continuously? So let's break down all the different parts of this word problem. 1,000 is what we're putting into the account. That is the A. 6% annual interest, that is your R. We're going to change that into a decimal of 0.06. How much money will be waiting at the end of 4 years? So that's talking about how X is going to go by, and it's going to be 4 years that we're waiting for this. And it says compounding continuously. So when you say that word continuously, that means we're just going to use that E equation that's in there. That's what we're going to use. So what I'm going to do is come around here and I'm going to start typing in my equation. Y will be equal to the amount we're starting with, which is 1,000. And then we're going to have the E equation. So that means the next thing that shows up is an E with an exponent. So I'm going to type in E, and I'm going to raise it to an exponent. The exponent's two things. It is your rate times the number of years. So it is a little different than the other exponents we're going to see. Your rate is 0.06, and we're going to be multiplying that times the 4 years that this goes on for. We're going to go over to the calculator and let that do the hard work. Now that we got our formula, our model set up, we're going to type this in. 1,000 times. Now, what the nice thing about the graphing calculators is that this E that's above the button that says ln, that actually brings the exponent open for you. So we're going to do shift ln, and then you can see the exponent kind of opens up automatically. And we're going to do 0.06 times 4 and close those parentheses to say both numbers are in the exponent spot. We're going to hit enter, and we're going to end up with a total of 1271 24. You might round that up to 25 in your delta math problems, since that would round up. So consider that when you go to complete the final part of this. But this is how much money we're going to end up with, which is slightly more than what happens if we compound it daily when we have 365. But this is the amount of money we're going to end up with if we compound continuously. So let's take a look at another example. We're going to put $12.50 in an account that is compounded continuously. So compound continuously, that's important, at 1.2%. How much will we have after 5 years? So we're putting $12.50 in, that's your A. Compounding continuously means that we need to use the E equation and not the other equation that we were using last time. And our R is only 1.2%, so it's going to be 0.012 is the decimal we're going to use for R. And our X is going to go on for 5 years. So let's type in our equation. Y, or the amount of money that we're going to end with, starts with $12.50. We're going to use the E equation and raise that to our R times the X. 0.012 times the 5 years. So in our calculator, we're going to see what we get. 1250 times E to the 0.012 times 5. So at the end of 5 years, we'll have $13.27 and 29 cents waiting for us in the account. So your next steps are to try the 2 practice problems on this document, and then you're going to go into Delta Math and you're going to finish our task for the week with practicing more of these problems that will kind of be randomly generated for you. So please read it carefully about how many times you're going to be compounding and all the different details about the percentages and things like that.